Hi everybody, so this video is for those of you who missed Monday's Zoom call, and basically we just had 3 proofs and they were all about the shapes that we actually did a while ago. We did these shapes in like December in Unit 4 when we had already done triangle proofs, but now we started to do proofs with other shapes. And for the opening exercise, the only really important things for this lesson is that you know for a trapezoid, you need to have one pair of parallel sides, which you can prove using the slope formula. For a parallelogram, there's a bunch of different ways you can prove that it's a parallelogram, and we'll talk about those when we get to the parallelogram question. We're not doing a rhombus in this lesson, but we will in the next. Rectangle we're going to do today as well, and I'll talk about that as it comes closer. And the square we're going to do in another lesson, okay? But you guys should be, pretty well versed on what these shapes are at this point because we've been doing them for a few months. We did take a little break about learning about them, but, I think most of you guys are still pretty good on what the facts are. But just to brush up on it, there's a link to a PDF that has all of these rules, and I linked that with the Zoom lessons. So you'll be able to see all of those things on Google Classroom as well. So for the first one, we are going to try and prove that this shape is an isosceles trapezoid. Now, an isosceles trapezoid has 2 things. One of the things is that it's a trapezoid, which means we need a pair of opposite sides to be parallel. And in our picture, we can see that AB and CD are going to be the parallel sides. And then since it's an isosceles trapezoid, that means that we're going to have the other 2 sides, so AD and BC, those 2 are going to have to be congruent. That's what makes it isosceles. So first, we're going to prove that it's a trapezoid, and then we're going to prove that it's an isosceles trapezoid. So our picture is going to look like that. We're going to have parallel sides, and then the other 2 sides be congruent. So to talk about the parallel sides first, we're going to have to compare the slopes, because slope tells us if they are parallel. And this is the slope formula. And the 2 sides we're going to do are AB and DC. And when you plug into the slope formula, you're going to get the same thing for both. And if you just had -1 or if you had -1/1, those are really the same thing. So it doesn't matter if you've got something slightly different there. And since those 2 have the same slopes, that means they are parallel. And if you have a quadrilateral that has 1 pair of parallel sides, it's going to be a trapezoid. So you have to make sure that you have the words as well, because the words are half of your proof. It's very important to have those, because that way we know why you did the slope formula. The other thing we need is that the other sides, AD and BC, are going to be congruent. And if they're congruent, that means they're the same length, so we're going to compare their distances. So we're going to do the distance formula for those 2. So the distance for BC, you plug it in and it looks like that. And your final answer, you can leave it as the square root of 20, but if you keep simplifying, you'll get to square root 5. It doesn't matter which one you have, because as long as you get the other one to be the same number, it doesn't matter what the number is. You can even write it as a decimal if you want to, as long as it's the same decimal. So now we know that it is a trapezoid because of this, and we know that the other 2 sides have the same distance, the same length. So that means that it's a trapezoid that is isosceles because it has congruent legs. The legs are the sides that aren't parallel. Okay, so that is it for example 1. Example 2 is about a parallelogram. So first let's look at our parallelogram properties. So this is that packet that I linked on Google Classroom with the Zoom meeting links. So the first one, our sentence would be, if both pairs of opposite sides are parallel, the quadrilateral is a parallelogram. We wrote that in our proofs in Unit 4. Okay, that was something that we did a whole bunch of. But now we don't have to write it as like a 2-column proof with the statements and the reasons and all of that stuff. Instead of writing it here, we're going to do the math first, and then we're going to write this sentence at the end. So the math that we would do if we were going to write this sentence is we would do slope, and we would do the slope for all 4 sides. And these 2 would be the same, and these 2 would be the same, meaning that those ones were parallel. You could also do the distance formula 4 times if you were to do this. Okay, if opposite sides are congruent, that's going to make it a parallelogram. Some people really, really hate slope and they like distance, and you can definitely do this. I think distance takes a little bit more work. It's a little bit harder to plug into the formula because you've got square roots and squares, but you can still do it this way. Definitely works. Another one is this one, where if you have one pair of opposite sides be both parallel and congruent, this way I think is the fastest way because you're doing both the slope and distance formula with the same numbers. So you can, repeat some of the numbers in there. I pointed out earlier how in the slope and distance formulas, if you're using the same line segment, you're going to get the same numbers in the steps. So you can use this one as like the shortest way. But if you hate distance, don't do this one. Do this one. If you hate distance, do slope. Don't even bother with doing stuff that you don't know how to do or you always mess up on or really struggle with. Okay? Do your strong suits. And then another one is if the diagonals bisect each other, it makes it a parallelogram. For that, you can do the distance formula 4 times for all of these if you want to, or you can find the midpoint of both and say that they have the same midpoint. That works too. You just have to do a little bit more explaining for that one. And then this one we don't know how to do. We don't know how to find the measure of angles in these proofs. Okay, so we're not ever going to use this one for these, but the other proofs we could. All right, so let's look at example 2. These are the ways that I think were the easiest ways to solve this proof. And I'm going to go with this one because it shows both distance and slope. That way you can see both ways. So we need one pair of opposite sides to be both parallel and congruent. I went with QU and AD. So the slope formula is that. And if we did the slope formula for QU, we would get this. And if we did the slope formula for the other one, AD, we would get this. Okay? And they're the same, -1/6, which means that those 2 sides are parallel. So that is one of our things checked off. Now we need to go for the other one. We also want to say that they are congruent. So since they're congruent, we're going to use the distance formula, because that talks about the length. And we're going to do the distance for the same 2 sides. QU is going to be the square root of 37, and AD is also the square root of 37. So we have the same distance, which means they are congruent. And since both of those are both parallel and congruent, that means it's a parallelogram. Okay, so this sentence came straight from this. Okay, it's the same words, just written a slightly different way. You could write it whatever way you want to write it. And you could do any of these other ones too if you wanted to. Okay, there's lots of different ways to do proofs. All right, and then the last one, we have a right triangle. We want to prove it's a right triangle. So that's something that we did in the previous lesson. So we're going to do the slope of the 2 sides that touch what we think is the right angle. And if they're negative reciprocals, then that means it is a right triangle because it would have a right angle. So looking at this picture, it looks like angle A is going to be our right angle. So we're going to find the slopes of AT and of FA. Okay, so let's find those slopes. So again, you're going to use the slope formula, and you're going to find the slope of AT and the slope of FA. And when you use the slope formula, you can do what the formula says and do m equals y2 minus y1 over x2 minus x1 and have x1, y1, x2, y2, and plug in, and that's how you would get AT. Or you could also just look at AT and count the boxes and do rise over run. So for AT, if we start on the left side, we have to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 down. So that means we're going to do negative 10 since we're going down. And over 1, 2, 3, 4, 5, 6. So negative 10 over 6 is the slope, which is the same as negative 5 over 3. So that could be our answer just by counting the boxes. You don't even have to do the slope formula if you can count the boxes accurately. Okay, so we're going to have negative 5 over 3. And then for the other one, you can do the same thing, or you can do the slope formula, it doesn't matter, and you're going to end up getting 3 over 5. Now you have to do either counting boxes or the slope formula. You can't just look at this and guess that that's going to be correct, because maybe you're not picking the right sides. Okay, you have to always do the math first and then make sure that you're right, not just, guess of what the sides are going to be for the slopes. So anyway, when we look at this, negative 5 over 3 and 3 over 5, those are negative reciprocals because one is positive, one is negative, and the top and bottom of the fractions have switched places. Okay, so we can say that FA is perpendicular to AT, and we know that because it's negative reciprocal slopes, and that means that the triangle is a right triangle. Okay, because we decided that angle A was a right angle because AT and FA were perpendicular. Okay, and every time I've done one of these proofs, I've written it a different way. So that's just to show you there's so many different ways you could write it. You don't have to write my words exactly, as long as you're getting your point across of why this is true. Okay, you're explaining it in your own way. This last part right here, we're going to try and find point E so that we make a rectangle, and then we're going to prove that it's a rectangle. So finding point E, you can do it a whole bunch of different ways. You can look at this and guess and check. We know it's going to end up being somewhere over here to make it a rectangle, right? But we don't know exactly where. You have to keep in mind that in a rectangle, the opposite sides are going to be both parallel and congruent. So if you picked a point that was like right here, when you connect these, they're not going to be parallel and congruent. Okay, this side needs to be parallel and congruent to this one, and this side needs to be parallel and congruent to that one. Okay, so when you pick your point, you got to pick one that makes sense and looks correct. So the actual point is going to be right here, point E. That's going to be 0, 6. And the reason that's going to work is because when you plot these, it's going to actually be a rectangle. And we're going to prove that that's the correct point because we're going to prove that it's a rectangle. Okay, so if you plug in 0, 6 for E, and you use all of these other numbers, we're going to have an accurate proof. So if we look at some of our rectangle rules, there's 3 ones that we used a lot in our other proofs. So the first one is if we have a quadrilateral, so any 4-sided shape, and all of the angles are right angles, then it's a rectangle. Okay, so that's one way. Another way is to first prove that it's a parallelogram, which you can use any of the other ways that we just mentioned for the other problem, and then prove that the diagonals are congruent. So we'd have to use the distance formula there. Or you can prove it's a parallelogram first, and then see that it has a right angle, and you can use the right angle that we already talked about over here. And that's enough to prove that it's a rectangle. And the first one and the third one are really, really similar. It just depends on what your wording is going to be. So what I'm going to do is I'm going to do this first one for our example, but you can still do the other ones if you like those other ones better. Okay, if you can figure out how to say, oh, it's a parallelogram because the opposite sides are parallel because their slopes are the same, and then go on to prove the other parts, you can still do that. I'm just going to show the first one. So if I want to prove that all 4 angles are right angles, that means I'm going to need a bunch of slopes. Okay, so I'm going to need to say that every angle, so angle F, angle A, angle T, and angle E, I need to say that all 4 of those are right angles. So to make angle F a right angle, that means I'm going to need to have FA and FE be perpendicular because that will make this a right angle. So let's do that. We need to say that FA is perpendicular to FE. And angle A, we actually did that already up here. That's FA perpendicular to AT. And this is my plan. I didn't prove most of these yet. For T, we need to say TE and AT. And then for E, we need TE and EF. Or FE, we could write that too. Okay, so those are our 4 angles. We need to prove all 4 of these things. And what's good about this is that most of these are repeated. Okay, these are the same, that's the same. So there's only 4 sides that we need to find the slope for, and we already did 2 of them in the first part of this. Okay, we have AT and FA, so now we need TE and FE. So the slope of TE, the slope of FE, and then we also have AT and FA. And we already figured those out, so we can keep the same numbers. So -5/3, and then this one was 3/5. Okay, so if you do the same process and find the slope for the other 2 sides, then we'll be able to make these connections. So if you look at TE and you count the boxes, then you're going to go up 3 and over 5, so 3/5. So TE has a slope of 3/5. And then FE, you're going to have to go down 10 and over 6, just like you had for TA. So that means that it's going to have the same slope. So we have -5/3, and that's our next one. So let's make sure that all of this is true using the information that we did with the math. So if we look at the first one, angle F needs to be perpendicular, or angle F needs to be a right angle, which means these 2 need to be perpendicular, which means they need to be right angles. So FA is this one, and FE is this one. -5/3 and 3/5 are negative reciprocals, which means they are perpendicular, which means this is true, which means that this is a right angle. So we have 1 right angle so far. Then if you look at angle A has FA and AT. Both of those are also negative reciprocals, which means that this is perpendicular and this is also a right angle. The next one is TE and AT, and those are negative reciprocals, so they're perpendicular. This is a right angle. And then the last one, we have TE and FE. Those are also negative reciprocals, which makes it perpendicular, which means this is also a right angle. So you would write as your statement that all 4 angles are right angles in this quadrilateral. So you would basically write this sentence, right? All 4 angles in the quadrilateral FATE are right angles because of all of this, because they all have negative reciprocal slopes. And you could write the slopes in all of the steps that we wrote. And since all 4 angles are right angles, then it is a rectangle. And that's it. And if you don't like that way, you could say one of these other ways. So like if we looked at it being a parallelogram, well, this is a parallelogram because you have two pairs of opposite sides that are parallel. Those 2 are parallel, and then these 2 are parallel. So since you have 2 pairs of opposite sides that are parallel, that is this one. We did the slope 4 times. We got the opposite sides being parallel. So that proves it's a parallelogram. Then you can use the distance formula to find the lengths of the diagonals, make sure those are congruent, or you can say 1 right angle, which we've already done. So anything like that will work. There are lots of correct answers for this one as well. Okay, but most of it is going to involve using the slope at some point. And then for the homework, you're going to first prove that you have a parallelogram. So that means you're going to look at example 2 and do something close to what we did in example 2. And then for this, it says we're going to prove that what we did up here is not a rectangle. Okay, so we haven't done any proofs where we say not at all yet, but what we're going to do for this is you're going to prove it's not a rectangle by proving it does not have a right angle. Okay, because if you have a parallelogram, oops, that was a terrible parallelogram. That's a little better. So if you have a parallelogram and you stand it straight up so that it's got right angles, then it becomes a rectangle. If it doesn't have a right angle, then it's not a rectangle. So we're going to prove that the shape is like that because we're going to say that it doesn't have a right angle. And we know that you can get right angles by having negative reciprocal slopes. So we're going to prove that there's not negative reciprocal slopes. So you just need to show that there's something that's not negative reciprocals. And that would prove that the angles are not right angles, and then that's enough to say it's not a rectangle and it's just a parallelogram. Okay? So if you have any questions on any of that, make sure you let me know. I have the homework part of this posted on Google Classroom, so you could submit it right away. And that's it.